So good afternoon, everyone, and welcome to the lecture. This is probably the last lecture on electric current, and we will be dealing with charging and discharging of capacitor in this particular class. So without wasting any more time, let us start. The first heading that we are going to write. Up till now, what we had seen in the chapter on capacitance was the capacitance. We had seen what is the charge coming on capacitance. In this particular topic, we are going to see how the capacitor gets charged. So the first heading is charging of capacitor. Now, what do I mean when I say charging of a capacitor? I will have a simple circuit where I have a capacitor C. Now remember, whenever I make a circuit, no matter what happens, the circuit would have some resistance R. This resistance R is the total resistance of the circuit, which includes the resistance of the wire, which we have put, the resistance of the battery, which is already there. E is the EMF of the battery. R is the total resistance of this small circuit. We understand this? Yes or no? Do we understand this? Are we there in the class? I'm
Sir,
talking. Right. So what happens? There would be a switch in the circuit. I have not drawn the switch. So what I'm going to do is draw a switch as well. This is a switch. Now at time t is equal to 0, you put the switch on and the capacitor starts to get charged. The current in the circuit will flow like this. This plate of the capacitor will get positively charged, and this plate of the capacitor is the other plate will get negatively charged. Now while the capacitor is getting charged, is in the process of getting charged, normally it takes a very small interval of time, milliseconds and microseconds it takes to get charged. But in that milli or microsecond, the charge of the capacitor keeps on changing. That stage when the capacitor is getting charged is known as the transient state. Transient state. Now this transient word comes from the word transit, and I've already told you what is transit. Transit means in transfer. So the charge on the capacitor is continuously going to change. Now after a long time, again when I say long time, that long time may even be just 1 second, maybe even 1 microsecond, maybe even 1 millisecond. The capacitor is going to get fully charged. When the capacitor gets fully charged, that is the charge we say, the charge on the capacitor at infinity or in steady state. So when the capacitor gets fully charged, the capacitor is said to be in steady state. Do we understand this? Steady means it will now remain constant. Transient means it will keep on changing. So when the capacitor gets fully charged, we say that the capacitor is in a steady state. Do we understand this?
sir,
The capacitor is fully charged, we say that the capacitor is in steady state. Now that charge, I will call it as Q infinity. That means the charge after a long interval of time. And that charge we already know will be equal to C into E. That is the charge that is going to come on the capacitor when the capacitor gets fully charged. Yes or no? That is known as
sir,
the charge, the steady state charge on the capacitor. When anyone is asking you what is the charge on the capacitor, if he has not stated any time, that means he is asking you the charge when the capacitor gets at steady state or when the capacitor gets fully charged. Do we understand this?
sir.
Now, between the time t is equal to 0 and t is equal to infinity, again I must tell you that this time interval is very, very short. The capacitor ka charge will keep on changing, and we can find out how the charge on the capacitor varies. I will just write the equation. I'm not going to solve it. I'm just going to give you the result. At any time, let us say the charge on the capacitor is Q. At any time, let us say the charge on the capacitor is Q. So what I'm going to do is write the equation. You remember that Kirchhoff's law? I will write
Sir,
the equation of Kirchhoff's law starting from point A. Now the only problem here is we have both capacitor and the resistor. The equation can be solved by integration. So if I write the equation for this capacitor, for this loop moving like this, the equation will look like this. Can anyone tell me what does the equation look like?
A minus Q by C minus
A
IR
minus Q by C minus
minus IR plus E
plus E will be
equals
to
VA.
VA. Yes or no?
Sir,
This equation has Q and I. Now remember, this I can be written as dq by dt, because this is the rate of change of charge or the rate of flow of charge. You can solve this equation in terms of q and get the value of q as a function of time. I'm not going to do that. That is not going to serve any purpose. We are just going to look at the result and see, take things from there. So the charge on the capacitor at any time q will be given by this formula, Ce into 1 minus e to the power minus t by rc. That is how the charge on the capacitor is going to come. Again, I have not solved the equation because that is irrelevant to what we are discussing here. So this will be the charge on the capacitor as a function of time. You can put different values of time and you can get the value of charge at that stage. This equation can be written in this fashion also. Q is equal to Q infinity into 1 minus e to the power minus t by tau. This term r into c is written at tau. This is how it is normally written, and that is why I have written it in this fashion. So this is the normal way in which you will find this equation written in books. You must understand here that what does Q infinity stand for? Q infinity stands for the steady state charge, which is C into E. This tau has got dimensions of time. This tau has a dimension of time, and remember this. And this tau is known as the time constant of this charging circuit, and the time constant of this charging circuit will be equal to R into C. R into C has the dimensions of time. You must remember this. Do we understand this?
sir,
We understand this? Everyone has noted this down? I'll give you two
putting
minutes.
sir,
Everyone has noted this down?
putting sir.
Okay, I'll give you 2 minutes to note it down. Now, whenever we hear the term tau or time constant, you must understand what is this, what does this refer to. So how do I get the value? How do I understand this time constant? If I put the value of t as 1 tau, if I put the value of t as 1 tau, I will get this charge q as Ce into 1 minus 1 by E, because tau and t becomes equal to tau, e raised to power minus 1, it becomes 1 by E. It becomes 1 by E, and that comes equal to 0.63 times. Why I'm writing 0.6 C? 0.63 times C into E, or you can write it as 0.63 times the maximum or the steady state charge. So that is how you can define 1 tau or time constant. 1 tau or 1 time constant is the time taken by the charging circuit or the capacitor to get charged to 63% of its maximum value. 1 time constant is the time taken by the capacitor to charge to 63% of its maximum value. Do we understand this?
Sir.
And you must also understand this graph, the graph between the charge on the capacitor as a function of time. This graph has come many times in many exams, and you can see when the time is equal to time constant tau, the capacitor gets charged to 63% of its initial value. Do we understand this?
Sir.
This is how we can find out the charge on the capacitor as a function of time, and that is how we define the time constant of a charging circuit. You can understand that this is a exponential curve. So theoretically the charge never becomes equal to E into C, but after a long interval of time we can assume that it is very close to C into E. It's an exponential curve, it will never become C into E. Do we understand this?
Sir.
This is the graph of this is the graph of Q versus T for a charging circuit of a capacitor. Do we understand this?
Sir.
Time constant, if you want, you can write the definition of time constant. We have drawn this graph, yes or no?
Sir.
Time constant is the time during which the capacitor charge on the capacitor rises to 63% of its maximum value. The maximum value is R into C. Everyone understands this? Yes or no? No or yes?
Sir.
Okay. Now, once you have the formula for charge on the capacitor, you can write the potential difference across the capacitor as a function of time. So how can you write the potential difference of the capacitor as a function of time? You just divide the equation of charge by C and you will get this formula. Potential difference will be E into 1 minus e to the power minus t by RC. Do we understand this?
Sir.
That is the potential difference across the capacitor as a function of time. It is also an exponential curve, same curve. The only thing is it is not multiplied by C. If you want to find out the current on the capacitor, the current flowing in the circuit as a function of time, you just need to differentiate. The equation of charge. And what do you get when you differentiate the equation of charge? You will get E by R into e to the power minus t by RC. So this becomes your current in the circuit as a function of time. You can also write this equation in this form. I is equal to I max e to the power minus t by RC. Where what is this I max? Or you can write it as I naught. This value of I max is E by R. That is the maximum current that flows through the circuit. Now, a very important thing that you can understand from the equation of this time, from this equation of current, at time t is equal to 0, current I is equal to I max is equal to E by R. Do we see this? Yes or no?
Sir.
At time t is equal to infinity, that means after a long time when the capacitor has reached its steady state, I becomes equal to 0. That means there is no flow of current when the capacitor becomes fully charged, and that is a very important result, that as the capacitor becomes charged, fully charged, the current in the circuit becomes 0. There is no flow of current when the capacitor is charged. A very important result. At steady state, when the capacitor is fully charged, current becomes equal to 0, or you can say the capacitor blocks current. In fact, this time of charging is very, very small, and therefore we always say that capacitors blocks DC current, because not even a second, in some milliseconds it will get fully charged, and then it will not allow current to flow through the branch in which the capacitor is placed. Do we understand this?
Sir.
Now we are going to come to a chapter where we are going to understand AC. In AC, resistance will offer opposition to flow of current. Capacitor will also offer resistance to flow of AC current. Inductor will also oppose the flow of AC current. Now, if I think of capacitor as a resistor, because you can see at time t is equal to 0, it is allowing maximum current to flow. But at time t is equal to infinity, it is not allowing current to flow. So I can think, I'm just thinking, it is not actually so. I can think of capacitor as a variable resistor whose resistance varies as it gets charged up. When the capacitor is uncharged, it behaves as zero resistance. It does not offer any resistance to DC current. DC current flows just like that. But as soon as the charge on the capacitor starts to go up, it starts to block current and it starts to offer resistance. So I can say in that way, at time t is equal to 0, capacitor behaves as short circuit. Do we understand what I'm saying? Do we understand what I'm saying?
Sir.
Or the resistance of this capacitor becomes equal to 0. It behaves like it is not present in the circuit. But after a long time, this capacitor behaves as open circuit. Or I can say the resistance offered by the capacitor becomes equal to infinite, and it will not allow any current to flow through this. Do we understand this?
Sir.
Everyone understands what I am writing here?
Yeah.
This is charging of the capacitor. Also, you can write at time t, at time t is equal to tau, current in the circuit becomes E by RE, or it becomes I max divided by E, or it becomes 0.37 times of I max. So from here also you can define the time constant of a charging circuit. It is the time taken by the current to fall from maximum value to 37% of the maximum value. Do we understand what I am telling you? Yes or no?
Sir.
Yes or no?
Sir.
Akka,
Yes, sir.
these are the questions that are um, more likely to be asked. There are other questions also that they can ask, so you can just write it. Once you know the value of everything, you can find out almost everything. For example, what is the energy stored in the capacitor at any time? If you want to find out the energy stored in the capacitor, what you can do, you know the value of Q, you can take the square and divide it by 2C. That will give you the energy stored in the capacitor as a function of time. Do we understand this?
Sir.
You can also find out the power given in the form of heat in the resistor. You know the value of I, you take square and you multiply it by R, and you will get the power lost in the form of heat as a function of time. Do we understand this?
Yes, sir.
So these are the questions that are supposed to be asked. I've given you everything that could be asked. I hope you are able to understand what has been told. Yes or no?
Sir.
Everyone has noted this down.
Think, sir.
Okay. Note it down. Let me know once you are done. So let's move on. Remember, any question that comes in this transient state will have e to the power something. So you will have log coming somewhere. You cannot maybe solve the value of log unless the value of log is known to you, but you can solve to a stage where you get to the final result in terms of log or e raised to power something. And that is what I just wanted you to find out. This is a question taken from your favorite book. Let's see if you can solve this one. Question number 1 comes on: a capacitor is connected to a 12-volt battery to a resistance of 10 ohms. It is found that the potential difference across the capacitor rises to 4 volt. You can see how much time it has taken. 1 microsecond. 1 microsecond becomes 1/3. So maybe in 5 or 6 or maybe 10 microseconds it will become maximum. So that is the time it takes to charge the capacitor. That is the only reason I have given you this question. Find the capacitance of the capacitor. You may not be able to get the actual value, but how far you can get, you can take it to that point, and then we can leave the result. Do we understand what I'm saying?
Sir.
You have 2 minutes to give me this answer. So how are we going to do this? I've already given the formula of potential difference across the capacitor. V is equal to E into 1 minus e to the power minus t by RC. Now the voltage across the capacitor plates is given as 4. 4 is equal to 12 into 1 minus e to the power minus t by RC. 1 by 3 will be equal to 1 minus e to the power minus t by RC. It's all maths. Physics is nowhere. If you just see, physics finishes in this first step. After that, it is all maths. E to the power minus t by RC becomes 2 by 3. So if I solve this, I get what? T by RC will be natural log of 3 by 2. So C becomes T divided by R into natural log of 3 by 2. Time is given as 1 microsecond, 1 into 10 to the power of minus 6. divided by resistance is given as this, ln of 3 by 2, whatever it is, and you will get your answer somewhere in the 10 to the power minus 7 range. I don't know where you were living, but in this universe, this is the answer. This is how far I can solve it because I don't know ln 3 by 2. Do you understand this? How this is done in this universe? Do you understand this?
Sir.
Pakka? Whenever you
Sir.
get any answer, think about what you are getting first, other than just saying it. 10 raised to the power 5 farad is impossible in this universe. Anyways, I hope we have understood the concept behind this. Everyone has understood this? I cannot solve further than this unless until ln 3 by 2 is given to me. So this is how I solve it. Now this question, instead of giving it as a voltage, it could have been given in terms of charge. Doesn't matter, the same equation comes. It could be given in terms of current. Doesn't matter, the equation of current comes. It all boils down to something of this nature. Do we understand this?
Sir.
Then I have this question for you. You can take it as a question or you can take it as a concept, doesn't matter. Now I have two capacitors, initially uncharged. Remember, we are not going to deal with capacitors who already have a charge. That question only comes more likely to come in JEE Advanced. We are not, we'll do it after our mains if required. Both the capacitors are initially uncharged. The battery is E. This capacitor is C1. This capacitor is C2. The question is pretty simple. Find charge, potential difference across each capacitor, and current as a function of time for this circuit. I'll give you 2 minutes. Don't have to actually do it. If you understand the concept, you should be able to tell me what would be the ultimate result. So I'll give you 2 minutes to think about it and tell me what answers are you getting. I hope you have understood the question, everyone.
Yes, sir.
I'm waiting for your answers then. So how are we supposed to do this? It's the simplest question in the entire universe. What you got to do, both the capacitor, understand they are initially uncharged. Both the capacitor are in series. You can find out the equivalent resistance. Then it becomes one capacitor with R. And I can straight away write the answer from what I have understood about this circuit. The charge on the capacitors, remember, both are in series, both are initially uncharged. The charge on each capacitor would be same. I'm going to write the charge on both the capacitors together. Q will be equal to E multiplied by the equivalent capacitance. C equivalent 1 minus e to the power minus t by R into C equivalent. And you must remember, what is this C equivalent equal to? Anyone? No one remembers it?
Sir. Thank you, sir.
Yes? No one remembers it. C1 C2 upon C1 plus C2. So you just replace it and you get your answers. If I have
Sir.
to,
Thank you, sir.
yes, beta,
C by 2, sir.
C by 2, sir. I don't know which universe you are living. In this universe, it is C1 C2 upon C1 plus C2. I never said both are equal. Please stay in this universe. Take a deep breath and stay in this universe. It is good. F is equal to MA. 4% of it is what we see. Remain in this one. I know you want to venture into other dimensions. There are very fascinating dimensions out there. Very fascinating universes out here in the multiverse. We remain in this. C1 C2 upon C1 plus C2. Having given you the charge, can you tell me what will be the potential difference if I call this potential difference as V1 and if I call this potential difference as V2? Can you tell me what will be the potential difference V1 and V2 equal to? So I'm giving you a chance to stay in this universe and give me the answer for this universe, not other one. I also want to get into another universe where I'm doing something else. Yes? Can anyone tell me the value of V1? And it will not take rocket science or quantum physics. V1, anyone? V1, anyone? No one? Okay, so this the only formula that we studied in capacitance was Q is equal to C.
C2 by C1 plus C2 into V.
Let me write the formula here. V1 will be equal to Q by C1. So your answer would look like this. E into, not C1, I'm also venturing in some other universe. E into C2 upon C1 plus C2, 1 minus e to the power minus t by c into R equivalent. When I asked you V1 and V2, I asked V1 and V2 as a function of time. Sorry, I did not specify that. That is a fault on my part. But when I asked V1 and V2, they were as a function of time. It was written in the question, in this universe at least. Now, having given you the value of V1, can you tell me the value of V2 from this universe only? Where F is equal to MA is valid. Yes. What will be the value of V2? The potential difference across the second capacitor is a function of time. Yes. Okay. So it will be Q divided by C2. If I divide Q by C2, I will have E into C1 upon C1 plus C2 into 1 minus e to the power minus t by R into C equivalent. The only thing that is left now is to give you the value of current. Can I expect that you can give me the value of current? Current in this circuit as a function of time. Yes? Anyone? No one? Okay, so it will be equal to E by R e to the power minus t by R into C equivalent. The only thing that has changed from this circuit and the previous one is that instead of C1 and C2, we have put C equivalent. So Q and I we get in this fashion. To find out the value of V1 and V2, we divide Q by C1 and we divide Q by C2. If I may ask, the last question that could be asked, what is the potential difference across the register as a function of time? Can anyone tell me that? VR. VR. Can anyone tell me the value of VR? The potential difference across the register as a function of time. Yes? Anyone? Any answer from any universe will do. If it is from this universe, better. Yes? Are we there in the class? I can't see anyone. It looks like everyone is gone into some other dimension. Lost there. Are we there?
Yes, sir.
Any answer for VR? It will be I into R. The only formula that we did in resistance was V is equal to IR. So we multiply this I by R. E EMF E raised to the power minus T by R into C equivalent. And if you want to check, you can check V1 plus V2 plus VR at any time. V1 plus V2 plus VR at any time. V1 plus V2 plus VR at any time will be equal to how much? V1 plus V2 plus VR at any time will be equal to how much? Hmm? No one
E.
knows. E. Chalo. We are still in this universe, which is a good one. And we are proud of this universe. F is still equal to ma. And simple laws of physics are valid. I'll give you 2 minutes to note this down. Take a deep breath. You cannot look at the stars right now. It's daytime. Imagine the universe, 4% of it. It's a wonderful one. Take your time, understand this. Once you are done, let me know. Then comes this question. The switch is closed at time t is equal to 0. I'm not going to ask you everything because once you understand one, once you get the value of one thing, you should be able to get the value of the other things. I'm only asking you the most obvious question. Charge on the capacitors as a function of time from this circuit in this circuit. Charge on the capacitor as a function of time. And I'll give you 2 minutes as time from this universe. Okay then. So I'll give you the answer. These two capacitors are in series. I can find out the equivalent capacitance. Equivalent capacitance of this system will be C1 C2 upon C1 plus C2. These two resistors R and R are in parallel. I can replace them by one resistor. The equivalent resistance will be equal to R by 2. Now I have one capacitor and one resistor connected, and I can straight away write the charge on the capacitors because the charge is going to be same. Charge on the capacitors as a function of time. Charge on the capacitors as a function of time would be E into C equivalent, which is C1 C2 upon C1 plus C2. I have space here, so I can write 1 minus e to the power minus t by r by 2 into C equivalent. I don't have the space, so I will not write it here. C equivalent is equal to C1 C2 upon C1 plus C2. That is the answer for charge on the capacitor as a function of time. Once you get the value of charge, you should be good enough to find out the value of V1, V2. I'm not going to that. I'll give you 2 minutes to note down this answer. Have you understood this? Yes or no?
Yes, sir.
Anyone got the answer?
Yes, sir.
Why did not you speak then? Anyways, note it down. Well, then there comes this question. Now, in this question, the charges on the capacitors are going to be different. I hope you understand this. If Q is the charge flowing in the circuit, Q1 is the charge coming on the capacitor, C1. Q2 is the charge coming on the capacitor, C2. What I wish to find out or ask from you, what is the value of Q, Q1 and Q2 as a function of time? Once you know this, rest everything can be calculated on its own. Q, Q1, Q2. If you differentiate Q, you will get current in the circuit and so on. So I'll just ask you the value of Q, Q1 and Q2 as a function of time, and you will get 2 minutes to give me the answer. So how are we supposed to do this? There are 1500 different ways of doing it. I will just use one of those ways. What I can do is take these two capacitors as one and find out the equivalent capacitance of this system. They are in parallel, so the equivalent capacitance simply becomes C1 plus C2. And this is in your time has gone and you said that you can't do it. Now you see and check whether your answer is correct or not. Now I can straight away write the value of Q, the charge in the circuit, as a function of time. So that will be equal to E multiplied by C1 plus C2 1 minus e to the power minus t by r into C equivalent. I have the space to write it, so I will write as C1 plus C2. That is answer, my dear friends, that I was expecting from you. Q as a function of time. Having got the value of Q, can anyone tell me the value of Q1? Anyone? No one? So this is the charge Q which is flowing in the circuit, and it gets divided into Q1 and Q2. If you remember sometimes back, many times I have told you how does charge divide in parallel branches. So from that concept, I can find out the value of Q1. Q1 will be equal to Q into C1 divided by C1 plus C2. I hope
Yes, sir.
you remember it. If I write it, it will be minus T by R into C1 plus C2. Anyone got this answer? If you got this
Yes, sir.
answer, then congratulations. Well done. Similarly, I can write Q2 as Q into C2 divided by C1 plus C2. So effectively, it will become E into
Even
C2
C2.
1 minus e to
Yes,
the
sir.
power minus t by r into C1 plus C2. Now, I'm not going to do that. If you differentiate this equation with respect to time, you will get I, which is the current flowing in the first branch, this branch I. If my dear friends, we differentiate this equation with respect to time, I will get the value of current in the branch of capacitor C1, I1. If you differentiate this, you will get the current in the second branch. I leave that task to you. Should not be asked, not even in a JEE advance. Do we understand this? Yes or no?
Yes, sir.
Or it has gone above our head saying bye bye. I'm going bye bye.
Understood, sir.
Bye bye.
Understood, sir.
Your understanding is difficult to understand. I hope you have understood this. These questions are very unlikely to come in JEE main, more likely to come in JEE advance. Let us move on to the third set of questions. And the third set of questions look like this. How does the third set of question look like? So I will make this question and I'll give you time to solve it. Take a deep breath and then solve them. And when I give you a question, you must understand that you know everything about that question that is required to solve that question. Here comes your question, which is more likely to come in JEE Advanced than in JEE Mains. This is resistance R1. This is resistance R2. This is capacitor C, and this battery EMF is E. At time t is equal to 0, the switch is switched on. The current in the circuit is shown in this fashion. The main current is I, this current is I2, and this current is I1. Take a deep breath. At time t is equal to 0, you have to tell me the value of I, I1, and I2. And I'll give you 2 minutes to think about this question. Think about it. If you're not able to solve it, no problem, I'll solve it for you. Yes, I heard something. Was anyone going to give any answer? No one? Okay. Then the answer is very simple. At time t is equal to 0, the switch is switched on. How does this capacitor behave? Does anyone remember? At time t is equal to 0, how does this capacitor behave? Anyone remembers it?
Transit.
You have not taken the newer resolution, or everyone has to take the newer resolution. And the only new Year resolution that you have to take is that you have to forget the habit of forgetting things. Whatever you write from your board, I know you are good at Xerox. You don't just Xerox it. That Xerox has to be in your brain. Let me repeat the same thing again. At time t is equal to 0, capacitor behaves as short circuit. It behaves as it is not present in the circuit at all. That is what you had to remember. Coming back to the question now. At time t is equal to 0, capacitor behaves as a short circuit. It behaves as it is not present in the circuit only. Now this is a very simple question. Two resistors are in parallel. What is the current through each resistor? So I can straight away write. I1 will be equal to E by R1. I2 will be equal to E by R2. And I will be equal to, and get your answer. This is the answers at t is equal to 0 seconds. Do we understand what I have done and how I have done this? Everyone
Yes, sir.
understands this?
Yes, sir.
Pakka? Pakka? No doubts? You understand how I applied the concept?
Yes, sir.
Pakka?
Pakka, sir.
The question changes now. And question becomes green. Now the switch has been closed and a long time has passed. Long time has passed means t has become infinite. T has become what? Infinite. Now I am asking you the same question. After a long time, what is the value of I, I1 and I2? Take a deep breath. Listen to the question. Understand what is asked and give me the answer. You will get 2 minutes to solve this.
Equals to 0, sir.
At t is equal to infinity, after a long time has passed, how does the capacitor behave?
Sir,
It behaves as
open circuits.
open circuit. It behaves as open circuit. That means it will cut off the circuit. It will cut off the circuit. If the circuit gets cut off, the branch in which capacitor is put gets cut off. Do we understand this? Do we understand this?
Sir.
When the branch of capacitor gets cut off, I2 becomes equal to 0. Do we understand this?
Sir.
There is only one way current can flow. Current can go gun 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 gun. This is the only way current can flow, because there is no other way for current to flow. Therefore, at time t is equal to infinity, I becomes equal to I1 and it becomes equal to E by R1. Do we understand this? Or this has gone above our head saying bye bye? I'm going.
Understood, sir.
I'm going in the second higher dimension where you cannot see me. Understand this?
Yes,
Yes
sir.
or no? Yes or no?
Yes, sir.
The last question that can be asked here is find the charge on the capacitor. Find the charge on the capacitor. That is the last question. Remember, the first question I asked was current at time t is equal to 0. Then I asked after a long time, what happens after a long time? Capacitor reaches its which state? Huh? After a long time, what happens? Nothing, sir, I don't know.
Open circuit, sir.
Capacitor reaches a steady state and the circuit of capacitor becomes open. You have to find the charge on the capacitor. That means you have to find out the steady state charge on the capacitor. When anyone asks you the charge on the capacitor, it always means the steady state charge on the capacitor. You have to find the charge on the capacitor steady state after a long time. I'll again give you 2 minutes. Think about it and give me the answer. So I have to find out the steady state charge on the capacitor, the final charge on the capacitor, the charge on the capacitor at infinity. To find the charge on the capacitor at infinity, what you have to do is you have to find the potential difference between these 2 points A and B. You have to find the potential difference between these 2 points A and B. Do we understand this?
Sir.
Now, remember there is no though there is no current in this branch. There is no current I2 in this branch. So potential difference between these 2 points is same as the potential difference between these 2 points A and B. Yes or no? Do we understand this?
Sir.
We have to find the potential difference between A and B and multiply it by C. And that is the answer. What will be the potential difference between A and B? Potential difference between A and B is potential difference across R1. Potential difference between A and B is potential difference across R1. Do we understand this?
Sir.
And that is simply equal to I1 multiplied by R1. Yes or no?
Sir.
I1 is E by R. E by R1. E by R1 multiplied by R1. Potential difference becomes E. Therefore, the steady state charge on the capacitor becomes C into E. And that is the answer that we are looking at. And that is how you have to solve any question where you have resistors and capacitor coming together. This is how you need to solve it. You need to find out the potential difference across the capacitor, and that is what is going to help you in finding out the final answer. Do we understand this? Do we understand this?
Sir.
I'll give you 2 minutes to note this down. Once you are done, please let me know. So here comes the next question. As expected, at time t is equal to 0, the switch is switched on. At time t is equal to 0, remember, switch is switched on. This is I, this is I1, and this is I2. At time t is equal to 0, switch is switched on. At time t is equal to 0, switch is switched on. You have to find out I1, and I2 at time t is equal to 0. Can you do that? Have you understood the question?
Sir.
Everyone has understood the question? Okay, then I'll give you 2 minutes to give me the answer for this one. 2 minutes you have. So, at time t is equal to 0, the Capacitor behaves like zero resistance. So what will happen? Current will start from here, ding, 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 ding,
0,
ding.
sir.
And the other side, the resistance is zero. So it will go ding, 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 ding. That is how the current will flow. So you can understand that at t is equal to 0, at t is equal to 0, I2 will become equal to 0. Everyone understands
Sir.
this? Becomes equal to E by R. Yes or no? No, yes.
Sir.
Anyone understands this?
Sir.
Yes or no?
Yes, sir.
Now give me the same answers at t is equal to infinity after a long time. What are the values of current after a long time? Can anyone give me those answers? I'll give you 2 minutes to give me the answer.
I2 is equals to epsilon by 2R.
Well done. At infinite time, this capacitor will block. It will become an open circuit. Current cannot flow in that branch. But current can flow. Current will go like this. Ding 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 ding. It can only flow like this. So at time t is equal to infinity, what happens? Your I1 becomes equal to 0, your I becomes equal to I2, and that becomes equal to E by 2R. Do you understand this? Yes or no? No, yes?
Yes, sir.
Anyone
Yes,
understands
sir.
this?
Yes,
Now,
sir.
the last question, find the charge on the capacitor. I'll give you 2 minutes to give me the answer for this one. So how I'm supposed to do this? I have to find out the potential across the capacitor, potential between this point A and this point B. Do we understand this?
Sir.
Now there is no current in this branch. So A point comes here and B point comes here. Yes or no?
Sir.
So I have to find out the potential difference between A and B. And what is the potential difference between A and B?
Into R, sir.
Potential difference between A and
Sir, Q is equals to C epsilon by 2R.
I2 into E by 2. Yes or no? It will be I2 into R. And I2 is E by 2R. Do we understand this? Do we understand this?
Yes, sir.
So what is the charge on the capacitor in steady state?
Epsilon by 2R, sir.
C into E by 2. And that is the answer that we are looking at. Everyone understands this? Yes or no? No or yes? Do we understand this, bacha? Do we understand this?
Sir, once again explain, sir, please.
What you did not understand? Which part?
Sir, where is R?
Where is R? Why R will come in the charge? You know how to find out the potential difference between A and B? How much is the potential difference between A and B? How will you find out this? How will you find out potential difference between A and B? Tell me. How do you find out potential difference between A and B? No one knows it.
By C, sir.
Yes, beta.
C.
See. Don't know what you're saying. It is I2 multiplied by R. It is a potential drop across the resistor R. It is I2 multiplied by R. The value of I2 I have taken from here at infinity. It is E by 2R. If I multiply it by R, I will get E by 2. That is the answer. Do we understand this? Do we
Yes, sir.
understand this? Say
Yes,
na.
sir.
Do we understand this? You have to find out the potential drop across the resistor. Across the resistor, I into R, I2 into R. You have already found out the value of I2. Multiplied by R. We get this. Still any trouble? Let me know.
Yes, sir.
What trouble? Any trouble?
Clear, sir. Understood.
Okay, this is the last question taken from your book. Find the charge on the capacitor. When any question comes on charge on the capacitor, you have to always find the steady state charge. To find the steady state charge, you have to find out the potential difference between these 2 points. To find the potential difference between these 2 points, no current will go in this branch. You have to find out the potential difference between these 2 points. Do we understand this? Do we understand this? Do we understand this?
Sir.
So
Sir.
please solve this question now. So how are we going to do this? We understand that there will be no current in this branch. Yes or no?
Sir.
Current will flow like this. Ding, 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 ding. Yes or no?
Sir.
What will be the current? What will be the current? What will be the current? Current will be 2 divided by 30. Total
Sir.
resistance will be 30.
Potential is 2 by 3, sir.
2 by 30. Now I have to find out potential difference between A and B, which is nothing but I multiplied by 10. Yes or no?
Sir.
So it will be 2 by 3 volt. This 2 by 3 volt has to be multiplied by the capacitance. This 2 by 3 has to be multiplied by the capacitance. 2 by 3 multiplied by 6. And the answer you will get will be 4 microcoulombs. Do we understand this?
Sir.
Everyone understands this?
Sir.
I am not getting response from all of you. Do we understand this?
No, sir.
What have you not understood? Which part?
Sir, once again, VAB, how?
What is the potential drop across the resistor beta? Only formula we have done in what is the potential drop across the resistor? If a current flows in the resistor, what is the potential drop beta? What is the potential drop across a resistor? You don't know it? If this is a resistor, the value of resistance is R and current is I. What is the potential drop across the resistor? You
Yeah,
don't
sir.
know? IR, sir. That is what I have done, sir. I into R, sir. What else I have done? Have I done anything different?
Yes, sir.
Take 5 minutes. Take a deep breath. Go through all the 3 questions. Once you are done, then let me know. Okay. If there is still any doubt, let me know. I'm giving you 5 minutes. Everyone, go through all these questions. Wherever there is a doubt, ask me. 5 minutes. So I'll give you one question, and I hope that everyone taking a deep breath, but able to understand what is asked. It's a simple question. This is a battery of 30 volts. Oh, sorry. Let me make it as. Let me make this as 10 ohms, and let me make this as 5 ohms. Everyone understands? Battery and 2 resistors. Everyone sees it? Yes or no?
Yes, sir.
Okay. I have connected 2 capacitors like this. This is a capacitor of 2 microfarad, and the green one is a capacitor. Oh, it's also blue. 4 microfarad. Anyone sees this question?
Yes, sir.
Yes?
Yes, sir.
Can you find out the charge on both capacitors? When I say charge on both capacitors, I mean charge at steady state. Can you find out the charge on both the capacitors at steady state? Yes or no?
Yes, sir.
How are you going to find it out? You must understand that at steady state, no current will go in this branch. Yes or no?
Yes, sir.
No current will go in this branch. Yes or no?
Yes, sir.
The only way current can flow is like this. Yes or no?
Yes, sir.
What is the value of current?
Yes, sir.
What will be the value of current?
Yes, sir.
2 ohms. Yes or no? 2 amperes. Yes or no?
Yes, sir.
Everyone got this? 2 amperes will be the
Yes, sir.
current.
Yes, sir.
Now you can find the potential difference between this point and this point, A and B. Yes or no?
Yes, sir.
How much will be that?
20, sir.
20 volt. You can find out the potential difference between B and C.
10.
Yes or no?
Yes,
That
sir.
is how
Yes,
much?
sir.
10 volts. Yes or no?
Yes,
Yes,
sir.
sir.
Now you can find out the charge on this capacitor. Yes or no?
Yes, sir.
How much will be the charge on this capacitor?
0.1.
60, sir.
Take a deep breath. Deep breath. You take the deepest breath possible in this universe. Now give me the answer. Take the deepest breath possible. What is the charge on this capacitor?
10.
The only
40, sir.
the only formula that we did in capacitor, please go back to it, is Q is equal to CV. V is 20, C is 2. So the answer would be
40, sir.
40, sir. Thank God.
40.
Thank God. Can you find out the charge on this capacitor?
40, sir.
40, sir. So that is how we find it, sir. Because no current flows in the branch. Do we understand this?
Yes, sir.
So in today's class, I was supposed to finish this one, but we could only finish charging of capacitors. Not a problem. Everyone has understood this concept of charging of capacitor,
Yes, sir.
or any doubt still exists?
Yes, sir.
Or everyone is clear with everything?
Yes, sir.
Okay, so I'll see you in the class tomorrow and we'll continue on discharging of capacitors in the next class. Take care and God bless you. Any doubts still? Please put it on the group, Telegram group, whatever, put it on my WhatsApp, anywhere. Any doubt, clear it, because this is the last time we are going to see capacitors in the next class. So any doubt, please clear it. Okay, beta?
Okay, sir.
I'll see you
Yes, sir.
tomorrow. Take care. Have a nice day, beta.
Happy New Year, sir.
Thank you, sir.
Happy New Year, beta. Bye bye.